semicircles today when it pops up. What we have with semicircles is we can arrange the equation of a circle to find the equation of two semicircles. Now, what we do is we just start off with our equation that has a centre of 0, 0 and a radius of r. So we'll have x squared plus y squared equals r squared. And what we want to do is we want to make y the subject here. So to make y the subject, what we have to do is we have to minus our x squared from both sides. So we're going to do that. And we will be left with y squared equals r squared minus x squared. Okay, from here, we're trying to make just y the subject, not y squared. So we have to do plus or minus the square root. So we get y equals plus or minus the square root of r squared minus x squared. And that is our equation of our semicircle, okay? Our circle is not a function, but when we split it into our two semicircles, it is a function, okay? What we have is that our equations of a semicircle with centre 0, 0, we have our y equals our square root of r squared minus x squared is the semicircle above the x-axis. Since y is greater than 0, our centre is 0, 0 and our radius is r. Now, if we have y equals negative the square root of r squared minus x squared, it's the semicircle below the x-axis. Since y is less than 0, our centre is 0, 0 and our radius is r. Okay, we're going to have a go at sketching these two semicircles and stating the domain and the range. So what we have is this is a semicircle in the form of y equals the square root of r squared minus x squared. So this one is fx equals the square root of 9 minus x squared. This means that a radius is going to equal what? 3, okay, because the square root of 9 is 3. What we'll have is it will go through our centre of 0, 0 is where our centre is. We have 3, 3 and minus 3. So we just draw our semicircle like so. Okay, and that is our function fx equals the square root of 9 minus x squared. Okay, our domain, when we're talking about our domain, it is all of the x values our semicircle can have. So our domain has the smallest x value of negative 3 and the largest x value is 3. So our domain is negative 3 to 3. Now our range is the y values it can have. So our range is our smallest y value is 0 and our highest y value is 3. So that means our range is 0 to 3 for that function. Okay, the next one is in the form y equals negative the square root of 4 minus x squared. So we'll have y equals negative the square root of r squared minus x squared. So our r for this one is the square root of 4, which is 2. Okay, because it's negative, it means it's going to be below our x-axis. So that means it's going to go through negative 2 and 2, and we have our centre is 0, 0. Okay, we can draw our semicircle. And write our function on there, y equals negative the square root of 4 minus x squared. Again, our domain is all of the values of x that it can be. So our smallest value of x is negative 2. Our largest value is 2. Then our range, our smallest value is negative 2. And our largest y value is 0. Okay, flip the page when you're ready. So they were semicircles created with the centre about the x-axis. On the next page, we're going to look at equations of semicircles with the centre 0, 0 about the y-axis. So far we've looked at semicircles that have been cut in half with a horizontal line. Now we're going to look at semicircles that have been cut in half vertically. So we can also halve the circle vertically to create two semicircles about the y-axis. This involves making x the subject of the equation. So we start with our x squared plus our y squared equals our r squared, and we're making x the subject. So to make x the subject of our equation of our circle, we have to minus y squared from both sides. So we'll get x squared equals r squared minus y squared. So x will equal the square root, or plus or minus the square root of r squared minus y squared. So it's pretty much just the same. It's just our x and our y's have swapped spots. Now, these semicircles are not functions. Okay, they're not functions because if we draw a vertical line, it crosses in more than one place. Okay, so our first semicircle is x equals the square root of r squared minus y squared. It is the semicircle of the function to the right of the y-axis. Since x is greater than 0, we have our centre 0, 0, and our radius is our r value. And then what we have is our other one is x equals negative the square root of r squared minus y squared. It's a semicircle to the left of the y-axis. Since x is less than 0, our centre is 0, 0, and our radius is r. It's terrible. Ditch the orange. Okay, sorry. The y-axis. That better? Okay. Now, I made a slight boo-boo with these and the equation's meant to be the other way around. So we are going to write the equations again, sorry. So it should be x equals the square root of 49 minus y squared for A, and B should be x equals minus the square root of 1 minus y squared. Okay, because of the graph that I've given you, like the axes that I've already given you. Okay, so our first one is in the form x equals the square root of r squared minus y squared, and that is where our r will equal 7. So what this means is we go through all of our parts of 7 that are on the right-hand side of our y-axis, and then we can draw our semicircle, not like that. That's not too bad. Okay, so that's x equals the square root of 49 minus y squared. Now we need to find its domain and its range. So our domain is our x values, so 0 to 7. Our range is our y values, negative 7 to 7. All right. Our last one here is x equals negative the square root of 1 minus y squared. So it should be x equals, it's in the form of x equals negative the square root of r squared minus y squared. And our r is the square root of 1, which is just 1. Now, because it's negative, it's going to be on the left-hand side of our y-axis, going through all of its 1 values. Oh, what happened there? I actually thought that was going to be a good semicircle. I'll have to do it again. Oh, bloody hell. That will do. Okay, so our domain for this one is our x values that it can be. So our domain is negative 1 to 0. and our range is -1 to 1.